For Unit 6, Lesson 3, we will be discussing differential rate laws. A rate law is just a mathematical equation that we use to express how concentration affects the rate. R in our equation stands for rate, K is our rate law constant, X and Y are our rate law orders, which we'll talk more about later, and then A and B are our concentrations of reactants. The order for a rate law tells us how a substance affects the rate. If we double our concentration and our rate stays the same, that substance would be considered zeroth order. If we double our concentration and our rate also doubles, we would say it's first order. For a second order reactant, we would double our concentration and see our rate change by 4 times as much. And a third order substance, we would double our concentration and see our rate go to 8 times as much. To determine a rate law, we have to use experimental data. First step is to write a general rate law. So what I like to do is plug in my reactants into my equation. So R, my rate, equals K, my constant, times my first reactant, fluorine, raised to a certain order, times the second reactant raised to another order. Now that I have a general rate law, I want to move on to step 2. I want to find my orders, X and Y, for both of my reactants. So to start with the first reactant, fluorine, I want to find 2 trials out of my 3 where Cl2 is constant but fluorine changes. So I'm going to look at trial 1 and 3. So looking at trial 1 and 3 for fluorine, I see I go from a 0.1 to a 0.2 concentration. So I double my concentration. Now I want to look at the rate for those trials. So I go from 1.2 times 10 to the third to 2.4 times 10 to the third, which also doubles. So because one doubles and the other doubles, 2 to what power is 2? That would be 1. So it's first order for fluorine. Now let's move on to the other reactant, ClO2. Again, we want to find 2 trials where fluorine is constant but Cl2 changes. So we want to use trials 1 and 2 for ClO2. Looking at trials 1 and 2, it goes from 0.01 to 0.04. So it quadruples in concentration. The rate goes from 1.2 times 10 to the third to 4.8 times 10 to the third, which also quadruples. To determine the order, we want to find out what 4 to what power gives us 4. And again, this is going to be first order. 4 to the first equals 4. The last step is to find the value of K, our rate constant. For this, we want to take the data from one of our trials, it doesn't matter which one you choose, and plug it into the equation and solve for K. Last, we want to find the units for K, which change depending on your rate law. So to get K by itself, we took the rate divided by both concentrations. Rate is measured in m per s, and we divided it by 2 molarities. So we're left with s to the negative 1, because it's on bottom, m to the negative 1 for our units. To sum up our rate law for this reaction, we have R equaling 1.2 times fluorine to the first order times ClO2 to the first order. K having a value of 1.2 and a units of s to the negative 1, m to the negative 1. For example 1, we want to determine the rate law and the rate law constant with units for the following reaction. First step is we want to write our general form of our rate law, plugging in our reactant, which is only 1 this time, to some power. Second step is we want to find the order for our reactant. Since we only have 1 reactant, it doesn't matter which 2 trials we select this time. Looking at trials 1 and 2, we go from 0.05 to 0.1, which we double, and our rate goes from 3 times 10 to the negative 4th to 12 times 10 to the negative 4th, which quadruples. So our order has to be 2 to what power gives us 4, and that should be second order. 2 to the second is 4. Now that we have the order for our rate law, our third step is to find K. We're going to take the data from one of our trials and plug it in and solve for K. Last, we want to find the units for K. So to solve for K, we took the rate divided by our concentration squared. So rate, molarity per second, divided by molarity squared. One of the molarities cancel, and we're left with S to the -1, M to the -1. And we have our final rate law for this reaction and our rate law constant with units. Pause the video and try example number 2 on your own. For question 3, we are already given our rate law with the orders plugged in. For part A, we want to determine the rate law constant. Here we want to take the trial data, any one of the trials will work, plug it into our equation, and solve for K. Pause the video and see if you can determine the rate law constant on your own. Now that we have a completed rate law and constant, we can move on to question B. What is the missing rate for trial 5? Here we want to plug in our concentrations for A, B, and C, and K, and find R. The last type of rate law question that you may be asked is to find the overall reaction order. To find this, all we have to do is add together the individual orders for each reactant. So in this example, we would add together 2, 1, and 1 for a total reaction order of 4.